All right, let's take a look at practice problem number 1 associated with sample problem F. George V's coast in Antarctica is the windiest place on Earth. Wind speeds can reach 3.00 times 10 to the second, that's 300, kilometers per hour. If a research plane flies against the wind with a speed of 4.50 times 10 to the second kilometers per hour, which is 450 kilometers per hour, relative to the wind, how long does it take the plane to fly between two research stations that are 250 kilometers apart? So let's start by understanding what type of situation we have. Let's do some labeling here. First off, we have this speed, which is the speed of the wind, okay, or I should say velocity. So we're going to represent that as a velocity. And this is how we're going to do the subscript, these relative motion problems. To use some subscripts to describe what type of velocity we're talking about. This is the velocity of the wind with respect to Earth. Okay, with respect to the actual planet. Okay, that is 300 kilometers per hour, which is 3.00 times 10 to the second kilometers per hour. And we have a velocity of the plane, okay, research plane is flying against the wind. So the plane with respect to the wind, traveling 4.50 times 10 to the second kilometers per hour, which is again 450 kilometers per hour. And even though these two velocities are working against one another, the plane is supposed to be traveling a complete displacement of 250 kilometers. So displacement 250 kilometers. Now, what we have here is a relative motion problem. We are being asked to find how long. Okay, how long? So we are trying to find a delta t, but in order to find a delta t, we're going to have to find a velocity, okay, velocity of the plane with respect to Earth, because the two research stations are 250 kilometers of Earth apart. Okay, so the plane, even though it's moving against this velocity, right, this velocity is cutting into this velocity, the velocity has to take the plane across 250 kilometers of Earth. Okay, so we're going to have to actually find the velocity of the plane with regard to Earth first. Now, in general, for these relative motion problems, when you're trying to find this, this velocity here, it's going to be a sum of these different velocities. In this case, we have velocity of the plane with respect to the wind, and then velocity of the wind with respect to Earth. Now, here's the issue. If I simply add these two velocities together, it's as though the wind was at the plane's back, and their velocities will add together to make one very, very fast-moving plane, around 750 kilometers per hour. Now, that's not what's going on. We see from the question that the research plane is flying against the wind. Against. So this wind is actually working against the plane. So in order to indicate that they are moving in opposite directions, we're going to have to slap a negative sign on one of them, right? Because we have to represent direction numerically. Now I'm going to make this velocity of the wind with respect to Earth the negative vector here, just to again say that with respect, okay, one direction, this plane is moving 450 kilometers per hour, And with respect to the same direction, because when you're doing mathematical calculations, you can't say north or east or something like that. In that same direction, this velocity is negative 300 kilometers, which would, numerically represents the opposite direction. Now, you might be wondering, why pick the 300 as opposed to the 450 kilometers per hour to be negative? Because when I actually plug these in, so we got 4.50 times 10 to the second kilometers per hour. It's going to be plus a negative velocity. Because if I plug it in this way, meaning the velocity of the wind with respect to the Earth is negative, my overall velocity will be positive. Positive means I'm actually making headway in the direction that the plane is moving. If the other way around, if I decide to make this value the negative vector, maybe because it was listed second in the, maybe that's how you do it. The first number you come to in a motion problem, you're going to call positive, you're going to establish as the positive direction, and the second, you're going to establish as the negative direction. Okay, that's a place to start, but here's the issue. A negative direction indicates the opposite direction of what you're talking about. And so it's actually much simpler to actually take just whatever's the smaller of the two numbers, make that your negative vector. Okay, make that your negative vector. Also, you can kind of conceptualize this a little bit. The plane is traveling faster than the wind, so it is going to make some headway. Right, 1.50 times 10 to the second kilometers per hour of headway. And so this should be, it makes a little bit more sense to have this be a positive value. Now, you can actually reason your way through doing it the other way. Like I said, having the velocity of the plane with respect to the wind be the negative vector. The only issue is in this next step we're about to start, you'd end up, right, when you're solving for time, you'd actually end up with a negative time. And negative time doesn't work good. All right. So we've figured out this velocity of the plane with respect to Earth, which means with respect to Earth, how fast is the plane actually traveling? So we're being asked how long is it going to take a plane traveling this velocity with respect to Earth to travel this displacement. And so we have a good old-fashioned equation to help us with that. Right? Our displacement is equal to the velocity times time. Obviously, right, how far you travel is dependent on how fast you're going and how long you're traveling at that speed. Now we have constant velocity, so that kind of plus 1/2 at squared. We're going to leave that out because we're not changing velocities at all. And when you don't change velocities at all, your value for acceleration is 0. And it kind of cancels out that entire part of the equation. But specifically, I don't want to use any old velocity, any of these. I want to use the velocity of the plane with respect to Earth, okay, that I just figured out down here, the plane with respect to Earth. So I'm not trying to solve for displacement. I already have a displacement. I'm trying to solve for time. So I'm going to have to rearrange this equation. All right, that'll cancel. So that I have an equation that solves for time, which is delta x over the velocity of the plane with respect to Earth. So what does that look like? 250 kilometers divided by, what was my value? Oh yeah, 1.50 times 10 to the second kilometers per hour. Put that in the calculator. So I'm using 3 sig figs. No, I should actually be using 2 sig figs, because this only has 2 sig figs. If there was a decimal point right there, I'd use, but as it stands, it's only 2. So it looks like I can only report 2 significant figures, and that would be 1.7. You can see I'm dividing a kilometers by a kilometer, so all I get is 1 over 1 over hours, which is the same hours.